It's been an incredible year. The SpaceX team, I think, is the best space team that has ever been assembled on the face of the Earth by far. And the achievements of the past year demonstrate that. I think to a degree that is mind-blowing. Like what you have achieved over the past year is nothing short of incredible. And one day, we will indeed occupy Mars. So let's go through everything that SpaceX has achieved that you've done. And it's actually going to take a while. By the way, this is going to take a minute. First of all, with Falcon, we have achieved the most launches of any rocket in a single year ever. So the next best was the Soviet Soyuz, which I think did a little over 60 launches in a year, and we did 96. So no other family of orbital class rockets has launched more than 63 times a year. That was Soyuz, and we did 50% more. Falcon Heavy also surpassed, in terms of heavy lift vehicles, the record for Saturn V, which I think did, with 5 launches last year, we exceeded the Saturn V record. So that was pretty incredible on Falcon Heavy. So this gives you a sense in pictures of how incredible that was. For a while there, I'd be posting something, is this like the launch that just happened or the one that is happening? Or because there were 3 launches that happened in the space of a few days. But this is all the launches on one page. And yes, it's really incredible. All made it to orbit, all landed. Just a huge hand for the Falcon team. That was incredible. And 2/3 of the missions were Starlink, but 1/3 were for other customers, for NASA, for other communication satellites. It was a combination of Starlink plus a lot of other missions. So even if you just take the non-Starlink portion of the flights, that was more than any other vehicle last year by a long shot. We launched NASA's Psyche, ESA's Euclid, the X-37B spaceplane, multiple transporter missions. We did missions for OneWeb, Viasat, and we're actually on contract to launch Amazon's Kuiper constellation. And we treat everyone fairly. So and we managed to do 19 flights on a single Falcon 9 booster, which is really incredible, in 3.5 years. So, and that booster did 860 satellites and delivered 260 metric tons to orbit. So it's like, wow. So there's a lot of wows. And it's worth, how long ago was it that we landed a booster? It was actually 8 years ago in December, roughly 8 years ago. And since that time, we've landed 260 times. So 260 landings. It's just like, wow. There were a lot of people that said that it couldn't be done. And then there were a lot of people that said, even if it could be done, it's a dumb idea. That it wouldn't pay off. That it wouldn't make sense. But we've shown that, in fact, it is absolutely the right idea. Reusability is the key to a great future in space. It's essential. We need reusability for rockets, just like we have reusability for cars, for airplanes, for bicycles, for horses. Obviously, reusability is essential. And the fundamental invention that is necessary for humanity to become a multi-planet species is a full and rapidly reusable, reliable rocket. I mean, it's incredible how much has happened in 8 years. I wonder what will things be like 8 years from now. Hopefully I think we will have landed on Mars, and I think we will have sent people to the moon, and maybe if we get lucky, we'll have sent people to Mars within 8 years. The key question, I think, about for civilization is, the key test, perhaps, for civilization is, do we make it through this Fermi great filter of going from a one-planet civilization to a multi-planet civilization? And if we do become a multi-planet civilization, we may go out there to other star systems and discover many long-dead one-planet civilizations. And we don't want to be one of them. That's lame. We don't want to be one of those lame one-planet civilizations. But I think we should always regard civilization as fragile, as not a situation where there is an inevitable upward trajectory. I mean, I read a lot about history, and if you read history, you see that civilizations are anything but permanent. Many civilizations have risen and fallen over the years, over the centuries and millennia. And eventually the sun will expand, boil the oceans, and destroy all life on Earth. Now, admittedly, that's, several hundred million years in the future, but it's only about maybe 10 or 20% of the existence of Earth itself. If Earth is 4.5 billion years old, then another 20% longer, and intelligent life would not have evolved. Because it's taken us a long time to get to this point. That's really the key test. Do we become a self-sustaining multi-planet civilization while civilization still exists, or don't we? I think that's really the key question. I think we've got a good chance, but it's not a sure thing. That's why time is of the essence. I think we want to make Mars self-sustaining as quickly as possible. It's not just a question of getting people to Mars, but it's getting enough tonnage and equipment to Mars to enable Mars to be self-sustaining. The key test being that if the resupply ships from Earth stop coming for any reason, does Mars die out or does it continue? That's really the fundamental threshold to pass the Fermi paradox great filter. The Fermi paradox is, where are the aliens? If life is common, if intelligent life is common, shouldn't we see a lot of evidence of it? Now, I get asked a lot about, aliens, actually. And I usually say I am one. Well, actually, I used to be, according to, Homeland Security. It said alien registration card, literally. I was like, okay. But the truth is, I actually have not seen any evidence of aliens, which I think is maybe a bit more troubling than if I had. I have not seen any, and I'd be on it. And you can pretty much guarantee that I would post about it instantly. Okay. I was like, yep, we got one. This is a spaceship for sure. But I have not seen anything. So that leads me to think that we're more likely to be a tiny candle of consciousness in a vast emptiness, a vast darkness. That the civilization that we have is really just this very small candle in a vast darkness, and we just must do everything possible to ensure that candle does not go out. Yeah. Anyway, I think we can do it. So, but we need to move fast, because you just never know. I mean, there could be, at any given point, like Stephen Hawking actually, I believe, said that he thought there was like roughly a 1% chance in any given century of civilization ending. That was his rough estimate. I think it actually might be higher than that. So we just want to go there fast. So this is getting back to Falcon 9, back to reality. These are all the launches we've done. And you can see how the cadence of launches has rapidly increased over time. And I think people online have actually assembled videos showing every launch. And it just gets like crazy fast as you get to 2023. Yeah, so we've done a 19.3 flight. We're now qualifying Falcon 9 to be able to do 40 flights. And we're aiming for maybe as much as 150 flights this year. So, and then let's not forget fairing recovery, because actually a lot of people don't realize we recover the fairing as well. This was actually very difficult to recover the fairing. So it costs an immense amount of effort. We now quite regularly recover the fairing, and we've reflown fairings 300 times. So congrats to the fairing recovery team. That was actually pretty damn hard. Oh, and then of course, we do operate basically a small navy. I think people don't always know that, but we have drone ships and support ships of various kinds. So we've got a small fleet of ships, and we operate them very efficiently. I think people also sometimes don't know the size. Like, you can see the size of the ship by the person walking around on it. It's not small. So it looks cool. I like this sort of, it's kind of a Darth Vader aesthetic, but I like it. So, and we're also getting much better with pad turnaround. We achieved a 3-day pad turnaround, and I think we're aiming to hopefully get under 24 hours pad turnaround by the end of this year. So in terms of, launch rate, so it's been 15 years since Flight 1 of Falcon 1. Flight 4 of Falcon 1, the first one to reach orbit. So 15 years since we got anything at all to orbit. Yeah, and now we're aiming to have 150 flights or thereabouts this year. So they're big rockets at this point. Falcon 1 is a little rocket. In fact, when I see Falcon 1 right now, I was like, man, I think I'd probably tuck that under my arm and just take it home with me. It was like, launch it in the backyard or something. It looks so cute. But at the time, Falcon 1 did seem like it was extremely difficult. It took us 4 flights to reach orbit, and it did seem kind of big at the time, but now it's like a adorable thing. Yeah. So I think the most profound metric, or the metric that really describes the magnitude of what SpaceX achieved in 2023 is the mass to orbit number. So, and you can see the incredible change just year over year. So 2021, we're slightly below rest of world. 22, I think, roughly doubled what the rest of the world did. And last year, we were 80% of all mass to orbit. So when rest of the world, we mean like the rest of US industry, Europe, India, China, Japan, everyone. So there's not a lot of industries where a company is doing like 80% of everything. And then what's really mind-boggling is that number should increase by 50% this year. So I guess on the order of like 90% of all mass to orbit, not counting Starship. So as we start launching Starship is like roughly 100 tons to orbit with every flight. There's a path to getting Starship to do over 200 tons with full reusability. So 200 tons to useful orbit with full reusability. And it's really an incredible amount. 1,200 tons of useful load to orbit last year. Yeah, that's just astounding. So I think that really deserves a round of applause. Like wow, I mean, that's the most mind-blowing, and the rate of increase is just astonishing. Now, these numbers will actually look very small in the future. In order to build a city on Mars, we'll need to be kind of in the million-ton to orbit range. So maybe a little higher, ideally a little higher, but sort of, if you just try to get things to the right order of magnitude, like not trying to get to an exact number, but try to get the order of magnitude right. I think it's on the order, it's roughly 1 million tons to Earth orbit. That'll get you roughly 200,000 tons to the surface of Mars. So roughly, approximately 20% of whatever you get to Earth orbit, you can get to the surface of Mars. And figure like maybe we need at least 1 million tons of useful load to the surface of Mars for it to become self-sustaining. That self-sustaining threshold is actually a very tough threshold to meet, because even if you're missing a tiny thing, then eventually that Mars will die out. So you've got to be able to not just build, for example, computer chips, but you need to be able to build computer chip factories. Because if you can't build computer chip factories, the factory that you do build will eventually break down, and then you will have no chips. And then that's it. It's kind of like a long sea voyage where if you're just missing vitamin C, yeah, you'll cruise on for a while, but then, your teeth will fall out and you'll die. That was a real problem in the old days. Anyway, it's quite a high threshold. And like Mars is a fixer-upper of a planet. It needs some work. So it's not like you can just run around outdoors and fish or live off the land. You can't live off the land on Mars. So it's really quite a lot of work that's required to make that work. So Dragon, an amazing amount of progress with Dragon and an incredible track record of success. So as of last year, the Dragon's fleet time on orbit exceeded the space shuttle fleet. So we had a cumulative over 1,300 days of time on orbit as of last year. So that's pretty mind-boggling that Dragon has now had more days in orbit than the entire space shuttle fleet. It's like, wow. So yeah, and Dragon has visited the space station more times than the space shuttle as well. So this is an incredible achievement by the Dragon team. So once again, as I was saying, this really has been an incredible, maybe the best year in the company's history. I mean, it was the best year in the company's history, actually. So there's a lot of great things to go through. And I'm not one who gives out false praise. So it's really mind-boggling what you've achieved. All of the missions last year used a flight-proven Dragon. So these Dragons had all flown before, and this year we're looking to fly maybe 7 or 8 Dragon missions. So it's really been, fantastic success by the Dragon team. This doesn't have audio. There's no sound in space. Yeah, that's a great looking spacesuit and in Dragon interior. So we've now sent 42 humans to orbit, to be precise. Space is relatively easy, but orbit is very difficult. So we've now taken 42 humans to orbit and back. And I have to say, if there's one thing I wish for, it is that we bring them all back safely. That's like, sometimes people say, well, what is the one thing you wish for? I say, I wish we bring the astronauts back safely. That is one thing. If I had one wish, that's what it would be. So, and we also have now completed a second crew arm in Florida. So we've got 2 towers that are capable of, 2 launch pads that are capable of sending astronauts to orbit. And this is going to be great for being able to shift missions between Pad 40 and Pad 39A. We've got this year our first spacewalk, and so we've got to redesign the suit so that you can actually move around in it, and you don't just pop out. Because if you just inflate the suit, you just basically, you're kind of like one of those balloons at a party or something, So it's quite hard to still be mobile in an inflated suit and have the joints move and stuff. And then we will actually evacuate the whole spacecraft. So everyone, even those that don't go on the spacewalk, will still be in vacuum. So obviously very important that it work. We don't have a little hole in the suit or something go flipping around. So, but I think, obviously we're going to put a lot of testing into this. But there's going to be another significant milestone, which is to have a suit where you can be in the vacuum of space with just nothing at all and just be out there. It's actually hard to conceive the concept of nothingness. And it's not technically nothing, there's a small number of particles per cubic meter. But it's pretty damn close to nothing. If you lose too much air, too much oxygen, that's it. There's no place to get oxygen from. So, an airplane, even at high altitude, can increase the pressurization pumps and get more atmosphere because it's in the atmosphere. Dragon springs an oxygen leak, and that oxygen leak is too significant. There is no place to get oxygen. You're just going to die. So the requirements for getting everything perfect are insane. Everything's got to be absolutely perfect to work. We did not, evolve to live in space, obviously. It's a tough one. But this is really going to be another great milestone, is to actually be able to have someone floating out there, in the vacuum of space and come back. And we do want to have a spacesuit that you can walk around in, because if you're on the moon, you want to be able to walk around on the moon, walk around on Mars. So having a high mobility spacesuit that actually isn't crazy expensive, ideally, and that you can walk around in comfortably is a big deal. It's actually an important thing that needs to be developed and ultimately made in large numbers. Because if we send, say, 1 million people to Mars, then that's 1 million spacesuits or 1 million Mars suits that you need. So we'll have to make a lot of these things. And we're also going to launch Starlink on that flight. So then coming to Starlink, this is only a whole separate company, but we're basically rebuilding the internet in space, which is pretty wild. And now it is, I want to emphasize, supplemental to the terrestrial internet. Sometimes people think, well, is Starlink just going to take over and destroy all the terrestrial internet? It definitely will not. But what it will do is Starlink will give access to the internet to people that either don't have access or where their access is extremely expensive or very bad access. So this is a massive enabler for improving and enabling people in remote locations to learn anything. Like, you can basically learn almost anything for free on the internet right now. Like, for example, MIT has all of its lessons on YouTube. You can learn almost anything if you've got an internet connection. But if you don't have an internet connection, you're limited to, I guess, maybe you got some books or something, but not. Basically, Starlink is a game changer for improving people's quality of life around the world. Like, this might be the single, well, certainly one of the, I think it might be the number one over time technology that improves people's standard of living around the world. It's certainly a candidate for potentially being the most profound thing that actually improves quality of life for people around the world, which would be really something to be proud of, obviously. And we're now introducing the V2 minis. This is next generation satellites that we've introduced into the constellation. And these are twice the capacity of last year, so from 88 terabits per second to 165. And our goal, the biggest single goal for Starlink from a technical standpoint is to get the mean latency below 20 milliseconds. So that actually makes it, for immediacy for actually the quality of internet experience, this is actually a really big deal. Also, if you play video games like I sometimes do, this is also important, otherwise you lose. So this is, anyway, that's actually a very hard problem, but because we're a low Earth orbit constellation, the speed of light is what do you think the speed of light is? 300 kilometers per millisecond. So if we're at 550 kilometers, think of it like roughly 2 milliseconds up, 2 milliseconds down. So if you go up, down, it's 8 milliseconds speed of light limitation. And then almost everything else we can actually address. Like, we can't go faster than the speed of light yet, but probably ever. But we can get the rest of the time, I think, below 10 milliseconds. And so then basically it'll be more responsive than ground internet in most cases, which is really what we're after here. So this is really amazing work. We also have now launched the argon Hall thrusters, which are very low cost and use argon, which is plentiful. So we've gone from using krypton, which is not that rare. I mean, if Superman did come here, I'd be like, you can get some krypton, and squirt gun or something like that. And okay, now what? Krypton is a noble gas that is, it's moderately rare, but we would actually be using a huge percentage of the world's krypton if we were launching that with the Gen 2 satellites. And so we moved to argon. And argon is actually extremely plentiful. In fact, right now you are breathing approximately 1% argon. So argon there's a lot of argon. But this is really I think the first significant argon Hall thruster, and certainly by far the most cost efficient and most power efficient. And it was a really great job by the Starlink team to create this thruster. And many other upgrades to then there's the in-space laser stuff. I mean, so this is by far, I think we've now sent at least 1,000 times more data, maybe 10,000 times more data over laser links in space than any other system before. I think we'll soon be like 1 million times more data transferred, maybe more than that, through the Starlink laser interconnects between the satellites. So we now have 9,000 active space lasers. So sort of vaguely reminds me of Dr. Evil, lasers from space. Actually, well, I guess I made that joke a long time ago. It's like Dragon does have LiDAR. It has like a laser for, docking with the space station. So it's like dragons with lasers. I mean, like, that'd be better than sharks with lasers. And each laser link is capable of 100 gigabits per second, and we're looking to increase that. So let's see. This is animation of all the places where Starlink is active. So obviously, a lot of the Starlink activations depend on country approvals. So as we are able to get a country approval, then you see rapid adoption within a country. And hopefully we'll get most of the rest of the countries will get the approval hopefully this year. And we'll be able to go almost worldwide. Some countries are probably unlikely to approve our system, but most countries we think we should be able to get to. And our goal this year is to activate service in more than half of the world's population. So that'd be fantastic. But I do want to emphasize, because we're all going to put this presentation online, it's supplemental to terrestrial internet. It does not replace it. It is Starlink it does really well for like low population density areas, but it is really not going to be competitive in high density cities, or it's really low density situations, which is really where the need is. So anyway, it works well with other internet providers, is what I'm saying. Then we've got community gateways. I'm told this is a town called Unalaska. It's a real place. So we're a lot more gateways down. As we increase the number of gateways, that improves latency. We've now shipped our next-gen hardware. That's version 4 of the user terminal. So it allows us to lower the cost of Starlink. And we'll be introducing the Starlink Mini later this year, which can fit in a backpack. So that'll be pretty cool for anyone who wants a very portable Starlink. And then we just opened our Starlink factory in Bastrop, Texas. So that's just a little, about 20 minutes away from Austin. And this is going to be, yeah. I guess some of you guys are part of that. Yeah. In general, we're going to have like a massive round of applause for Starlink. That is for sure, because there's like the achievement level there is amazing. Actually, let's just have a massive round of applause. It's like, goddamn. Yeah. Sorry, it's hard to clap with this thing. Yeah. The Starlink achievements are really mind blowing. So it's. Like the Starlink system is an anomaly in the matrix. And then we also just recently launched our first direct-to-cell satellites, and we were able to send text messages directly from a phone to the satellite and then back down again. So we did intentionally misspell these things, by the way. So although actually when I first saw it, I was like, is this real? It turns out it is in fact real. This is, some Dogecoin jokes, basically. So yeah, and anyway, so it's kind of amazing that you can actually close the link between a phone in your hand and a satellite that's hundreds of miles away. And the satellite can hear the tiny signal that your phone is outputting, which is like such a faint whisper, it's ridiculous. But it can actually somehow hear that faint whisper and be able to communicate with a phone is, I think, it's one of those things like, I wasn't sure, is that actually physically possible? But it is. Now, I do want to emphasize this is also not a competitor to phone companies. This is something that will be supplemental, so it's going to be very helpful for remote areas where there's no cell connectivity, or once in a while within a city, if there is a place that has no connectivity within a city, then Starlink will be able to communicate with phones. But I think it's something on the order of 7 megabits per second within a cell, and the cells are hundreds of square miles or kilometers in size. So it's good for text messages. You could technically do video if you're the only one, or if there's only a few people in that cell, like if you're in the middle of the Pacific or something like that, but it is something that is going to be very helpful and will, I think, save lives of people. If somebody's sort of hiking in a remote region and they get lost, well, now their phone could actually work, and I think it will actually save a lot of lives, which is cool. And then we have 7 announced partnerships. So we've got T-Mobile in the US, Rogers in Canada, Optus in Australia, One New Zealand, Salt in Switzerland, KDDI in Japan, and Entel in Chile and Peru. And we expect to announce a number of other telco partnerships this year. So this is definitely something where we're, again, in partnership with telcos. I just basically don't want telcos to get really mad at us. That's what I'm saying. We want to support the telcos. And then, of course, this is slowed down a little. But that first launch did take a while to get off the pad. When that took off, I was like, wow, I can't believe it took off. That was my reaction. So I think it's incredible that we took off twice last year. Even though I've been very closely involved with the Starship program from the beginning. And actually, I lived out here. This is my primary residence for 3 years. This used to be a sandbar, basically, what we're looking at here. And now it's got an advanced rocket factory and a gigantic launch pad, and we've got a whole bunch of rockets out there. But I'm still amazed that it actually got put together and it took off. I'm like, wow. I mean, the Starship is more than twice the thrust of a Saturn V. It is by far the biggest flying object ever made. And with some upgrades down the road, it'll actually be, I think, probably over 20 million pounds of thrust. And Saturn V is 7.5. So it'll end up being 3 times the thrust of Saturn. And it's going to fly a lot. It has to fly a lot. So it's going to end up flying several times a day from many different locations in the world. And I think there's a pretty good chance that it does Earth-to-Earth transport as well. Because the fastest way to get from one place to another on Earth is, to get from here to the other side of Earth is an intercontinental ballistic missile. But just make sure you delete the nuke and add the landing part. Basically, that's the fastest way to get somewhere. Yeah, wow. And then between Flight 1 and 2, we made a number of massive upgrades. So there was obviously a massive upgrade to the launch pad. So we've got like a mini Niagara Falls here. The water pressure is so much that if it went straight up, it would actually destroy the rocket. That's how much water pressure it is. So it's like, wow. And it worked. Like, oh, actually, went and looked at one of the first things I went and looked at after the second launch was to check out the launch pad, because obviously after the first launch we dug a pretty big hole, and honestly it looked like it looked like there was no damage at all. Like you could just launch again basically for the pad itself. So it's great work by the team to radically improve the launch pad overnight. People always like want to use the Statue of Liberty for stuff. Statue of Liberty is not that big. I was like, been there. I actually climbed up the Statue of Liberty in the tiny staircase a long time ago. But anyway, this is a big rocket, and it will get bigger over time. Yeah. So I don't know if you guys watched Kong vs. Godzilla. It's like one of the most insane movies I've ever seen, but it's like kind of entertaining in its sheer madness. And the crazy thing is that our launch tower is bigger than Mechagodzilla, and it's gonna do basically like the same thing, but with the arms, like catch the rocket. And when I tell people like, yeah, we're gonna catch the largest flying object ever with giant mechanical arms, they're like, there's no way that's real. I mean, we could give it legs too. Just give it legs and have it tromp around. That'd be pretty cool. And then we're also going to build a second tower. Yeah. We're going to really be launching a lot, and we're going to be upgrading one tower while we launch from another tower, so 2 towers is important. And there are actually so many upgrades between Flight 1 and 2 that it would actually take it like hours to go through them all. But one of the biggest upgrades was going from hydraulic to electric of the engines. So that actually saved a lot of mass and complexity. So yeah, the electric TVC, I mean, it was just, this is one of the biggest upgrades. We also massively upgraded the heat shield. The engines themselves were massively upgraded. Literally everything on the rocket was like, there might have been thousands of upgrades between Flight 1 and 2. So really gigantic improvement between Flight 1 and 2, and also obviously many improvements between Flight 2 and 3. And then we've got a whole development plan to, like I said, ultimately get to a fully reusable rocket that does over 200 tons to orbit on a regular basis. Full reusability. Yeah. Hot staging. I mean, hot staging was a change that was basically, I don't know, just really within a space of like 3 or 4 months, maybe less, going from, or roughly that, going from previously just separating the rocket without anything to actually lighting the upper stage engines while the first stage engines are still thrusting and not blowing up the ship, that was an amazing achievement. So I was like, wow, and it worked. So I was like, wow. So then let's look at Flight 2.
Attention all operators on countdown 1. It's the final go for Flight 2 of Starship. Energy 0 is at 7 a.m. Central. Raptor 1.
Go.
Raptor 2.
Go.
Stage 1.
Go.
Stage 2.
Go.
Copy, go for flight. Clock is rolling. 10, 8, 7, 6, 5, 4, 3, 2, 1. We have we're stretching.
So yeah, big round of applause, guys. Wow. So flights actually almost made it to orbit. So in fact, ironically, if it had a payload, it would have made it to orbit. Because the reason that it actually didn't quite make it to orbit was we vented the liquid oxygen, and the liquid oxygen ultimately led to fire and an explosion. We wanted to vent the liquid oxygen because we normally wouldn't have that liquid oxygen if we had a payload. So ironically, if it had a payload, it would have reached orbit. And so I think we've got a really good shot of reaching orbit with Flight 3, and then a rapid cadence to achieve full and rapid reusability. And I mean, kind of the mind-blowing thing is, like, there is an actual path that we are on to make life multiplanetary. Can you friggin' believe that? Like, what? We just got to get it done before civilization ends. But I think it's going to happen. Yeah, right here. So anyway, so in terms of getting there, we obviously want to accelerate the production and testing, get to a high cadence. For any given technology development, it is, how many iterations do you have, and what is the amount of time between each iteration? So every time we launch, or do a test, we learn something more. So increasing that cadence of launching and testing, and it's always better to sacrifice hardware rather than sacrifice time. Like, time is the one true currency. So it's sort of the fastest path to, as I was saying earlier, rapidly reusable, reliable rocket. Yeah, and we've got a block, sort of a version 2 ship that will be more reliable, better performance, endurance. We've got a version 3 ship design that will stretch, that be even taller, probably end up being, I don't know, 140 meters before it's all said and done, maybe 150 in the end, in length. Yeah, so it'll be even taller than it currently is. Yeah, and so with Flight 1, the goal was not to blow the pad up and ideally get some distance, which we did. With Flight 2, it was to get past staging So we achieved the goal of getting past staging and almost to orbit. And then flight 3, we want to get to orbit, and we want to do an in-space engine burn from the header tank and prove that we can reliably deorbit. We want to do a tipping point header domain propellant transfer. This is important for the NASA Artemis program. And we want to also demonstrate the payload door for the sort of PEZ dispenser for delivering the Starlink, the V2 non-mini, actually probably V3 technically, but the really giant satellites to orbit. Yeah. So, like I said, the mass orbit ultimately of Starship will be, over time, I think millions of tons of to orbit. So compared to present day mass to orbit, it'll be more than 1,000 times, more than 1,000 times greater than mass to orbit currently. That's what it will be eventually, or it needs to be. So we also want to demonstrate on-orbit refilling. This is very important for the NASA Artemis program. So we're very proud to be part of the NASA Artemis program. I'm always incredibly grateful to NASA for their support and for trusting us to take astronauts to orbit, to take cargo to the space station, and to be an integral part of getting astronauts back to the moon. One of the other questions I get a lot is, did we really go to the moon? I've gotten that from a lot of people, and I'm like, yes, we went to the moon. More than once, in fact. But the crazy thing is that it's been over half a century since we last went to the moon. So, I think maybe that's what causes people to be skeptical. Like, how come we can't go to the moon now? It was 66 years from the first controlled powered flight of the Wright brothers in 1903 to landing on the moon in 69. So only 66 years. 50 years have passed since we last went to the moon. But now we're going to go back there, and we're going to go back there soon. And we're not going to go I think, the next step, I think, is to build a moon base, like Moon Base Alpha. Make sci-fi real, not to remove the fi part of sci-fi. So, but in order to go and land on the moon, one of the technical challenges we have to solve is orbital refilling, where the starships dock on orbit and transfer propellant. Now, we've gotten very good at docking because we dock with Dragon to the space station, which is actually more complicated than docking with our own spacecraft. So we have a lot of expertise in docking, so I'm confident we will solve this. And we just ideally want to solve it, hopefully by the end of this year, but certainly by next year. And that's a big deal. This is one of the fundamental technologies that's necessary to build a city on Mars and to have a moon base. And then, we'll also be launching some very big satellites, world's biggest PEZ dispenser. And we do hope to do this by the end of this year. And then, more about the NASA Human Landing System. So, as I said, we're extremely grateful to NASA for entrusting us with a fundamental part of the Artemis program. We want to make sure we do a great job for NASA, and really we are a very fundamental part of the Artemis program. So if we do not succeed, which we will, but in order for the Artemis program to succeed, we must succeed with Starship. And like I said, we actually want to far exceed what NASA has asked us to do. So we want to go far beyond the NASA requirements and actually be able to put enough payload on the moon with enough frequency that you could actually have a permanently occupied moon base. That's the next really big threshold from Apollo, is have an actual moon base. I remember seeing this, kind of cheesy sci-fi show a long time ago called Moon Base Alpha. I don't know if anybody's seen that, but the moon actually drifts away from Earth. Now, this is not going to happen, but it was a cool show, Moon Base Alpha. But we need a real moon base Alpha, and we're going to do it. So then, as I was saying, this is the long-term goal. This is what we want Mars to look like. Starships coming and going, an incredible, beautiful Mars city, and a flourishing civilization on Mars. And ultimately, we can transform Mars into an Earth-like planet with terraforming. It just needs to be warmed up, really. And then it could be ultimately an Earth-like planet, and we could bring the life from Earth. We could extend life from Earth to Mars. And really, it has to be humans, because it's not going to be the dolphins. But we can bring all the creatures with us, and we can ensure that life on Earth continues on Mars, even after Earth becomes unlivable in the distant future. So anyway, I'll go into questions.